So we'll be doing this problem. Look at the problem on the screen. This problem is from exercise 3.12 Physics Ncert. So let us read the problem first. What is the numerical telling us about? Numerical is telling us about the ball which is being dropped from a height of 90 meter. If I have to draw that situation here, how can I draw it? We have a, let's say we have a ball. Okay, we have a ball like this. It is dropped from a height of 90 meter onto the floor, right? Okay, let's say this is the datum, that is floor. Now it is dropped from 90 meter, so its velocity will be directed downwards. Its velocity will be directed downwards, and it strikes the floor. Now it strikes the floor. Let us say now it bounces back. What will it do? It will bounce back. When it will be bouncing back, what will happen due to some, when you're bound, when you're putting the ball onto the floor absorbs some energy, the speed reduces. So the reason of reducing the speed is not important here, but the statement itself says that at each collision with the floor the ball loses how much? 1/10 of its speed. Ball loses 1/10 of its speed. Let's say if its velocity just before striking the floor was v, it was, let's say it is v. What is that? It is v. Then after, when it goes back after bouncing the floor, it will go back, right? When it is going back, it will go with the velocity, and the velocity will be upwards. What will be this velocity? Whatever the velocity was there, what was the velocity? The velocity was v. That velocity minus v by 10th. V by 10th is lost. That's why the velocity with which ball goes upwards will be v minus v by 10 meter per second. Here the velocity before it hits the ball was v meter per second. How much was it? It was v meter per second. Be able to understand? Yes. Now afterwards, from the same height, now it bounced back, then it will again come, right? So what is the total time span given? Time span is 12 seconds. That means what? It started from where? It started from t is equal to 0. T is equal to 0. Now this time I know? No, I don't know. Let this time be t is equal to t1. So from t is equal to t1, it is going to t is equal to t2. From t is equal to t2, it comes back to t is equal to t2. It comes back to t is equal to 12 seconds. That means what? When it came to t is equal to 12 seconds, I don't know. What I don't know? I don't know the, just wait a moment. I don't know whether it has reached the floor or not. I don't know whether it has reached the floor or not. Right? This is the physical situation now. This is what? This is the physical situation. Physical situation means this is what I have to make in my mind, that this is what it is happening. What is happening? Let me explain it again. It, the thing is, the ball is being dropped, right? This is the ball. It is being dropped from how much height? This total height is how much? This total height is 90 meter. From 90 meter it's being dropped, so velocity v, which was there, that velocity v from which is moving, which is directed downwards, it, with that velocity the ball comes and hits the floor. While it is hitting the floor, what will happen? It will lose the, now this velocity v means what? Velocity v will be increasing, right? Velocity v will be increasing. Velocity will be different at this point, at this point, at this point. The maximum will be before it reaches this point. So this velocity at this point will be v, right? Not at every point. It will be accelerated, right? Accelerated. So velocity will be increasing with each point, and at the just before the moment it hits the ground, the velocity will be v. Now with now it will bounce back. It will bounce back with velocity what? With velocity v minus v10, v by 10. That means 1/10 of the velocity is reduced, and the velocity will go on reducing the velocity because the ball is going against the acceleration. So it will go, the velocity will go on reducing, and here the velocity will be equal to what? Here the velocity will be equal to 0. So this situation, let's say this is bounce 2, say this is bounce 1 situation I'm talking about. So this is bounce 1. Now this is bounce 3. This is bounce 3, right? Situation 1, situation 2, situation 3. Did you analyze the problem now? The problem is properly analyzed, right? Now we'll go for the solution. Now if I know the what problem has to, that the problem has to say, right? What problem has to say, and I understood the problem. Now I will go for solution. What will be the solution? Now while solving the numerical, what I'll do, I'll divide the whole numerical to three parts. I am saying the first part as bounce 1. Part has bounce 1. What I have to do, I have to draw a diagram. Actually, I have to draw a diagram, plot the speed time graph, speed time diagram I have to plot for the situation. So I have taken bounce 1. What does bounce 1 says? Bounce 1 says that with the ball has been dropped from a height of 90 meters. So while it was dropping, what was the initial velocity for bounce 1? It was 0. What was the velocity? It was 0. Then what is the distance covered? That is s. Displacement will be 90 meter. What is the displacement? 90 meter. So, and time, time is equal to t1. That I don't know. That I have to find out. What will be the acceleration? Acceleration, always you have to understand, acceleration will be minus g when it is falling vertically, meter per second square. That is equal to minus 10 meter per second square. Let us take minus 10 meter per second square. And final velocity, that is velocity at this point just hitting the ground, what it will be, I don't know. So that I have to find out. So v will be, that also I have to find out. Okay, these two things I have to find out. Now let us use the formulas, kinematic formulas that we have. What are the kind of problems formula we have? S is equal to ut plus half at square. S is equal to ut plus half at square. Because displacement is also downward, this also will be minus 90 meter. What it is that? Let me cancel this. This will be minus 90 meter. Now S is what? Minus 90 meter. In this case, first bounce I'm talking about. Minus 90 meter. That is equal to, let us not write down the units. It will be confusing. Minus 90, U is 0 into T plus half into minus 10 into t square. What is t square? We don't know. Times with the time that we have to find out. T, what we have taken here? T1. What? T1. Here also T1. Right? T1, T1. So minus 90. So it will be what? Minus 90 is equal to 0 into T1, 0 minus half into 10 into T1 square into T1 square. So this will be minus 90 is equal to minus 5 times, this cancels out and this will be 5. So this will be minus 5 t1 square. Minus minus get cancels and t1 square will be equal to 90 by 5. What will be 90 by 5? So t1 will be under root of 18. Under root of 18. If we take out under root of 8, ball has taken to come to this floor is 4.24 seconds. Okay. Now what will happen? From this t is equal to, now this second bounce 2, right? Bounce 2. Bounce 2. In bounce 2 what will happen? From t is equal to 4.24 second, right? The ball will go back, bounce back and travel opposite to the acceleration due to gravity. It will travel this way. The displacement will be upwards. Displacement will be upwards. So S will be positive. Now I have to find out here velocity also. I did not find out the velocity. I found out only t is equal to t or is equal to 4.24 second. I found out. I did not find out the velocity. How will I find out the velocity now? The velocity for this will be equal to v is equal to u plus a t. V I don't know. I have to find it out. U is 0 minus g, right, minus 10 into t, 4.24. So answer will be minus 10 into 4.24 will be 42 point, wait a minute, 42.4 meter per second. So this is velocity. This is 42.4 meter per second. Okay, 42.4 meter per second. So from t is equal to 4.2 seconds, it goes upwards now. So what will be the velocity? Velocity is reduced by 1/10. That means 42.4. Which velocity? Velocity of this while during the second bounce. So it will be what? Velocity is upward. Now it is downward, right? Velocity was downward. That's why it is negative. 42.4 minus 42.4 of 10th. Don't take minus again here. We have to take only magnitude, right? Speed is reduced, not velocity. Speed is reduced, right? Don't take the direction minus. Minus of minus will be plus, so will add up. It is reducing. Therefore, you have to take only the magnitude. So 42.4 minus 4.24. So this will be exactly 37.8 something, right? The speed will be equal to 37.8 meter per second. This is the velocity. This velocity will be upward. It will be positive. We are talking about speed here. While drawing the diagram, we will see all things will be positive. You don't have to take negative one. So this will be 37.8 meter per second. Let us take another slide. Did you understand this? I'll repeat it again. What I have done is, this is a ball which is thrown from a height of 90 meter. Okay, this is bounce 1. I'm taking it as bounce 1. It is coming down, so velocity will be increasing, and at a point before reaching the ground, the velocity will be how much we have found out. How much? 42.4 meter per second. And what is the time that it will take? It will take 4.24 seconds. How much? 4.24 second. Now what will happen? It will bounce back. While bouncing back, what will happen? The velocity with each bounce, the velocity is reduced by 1/10. So 1/10 it will reduce. Whatever was the velocity here, that 1/10 value, by 1/10 value of that velocity, it will reduce. That means 42.4 was there, so it will reduce by 1/10 of that. 42.4 divided by 10. So what will be the velocity? 37.8 meter per second. That means with 37.8 meter per second, it will rise. While rising, the velocity will reduce. At this point, it is what? 37.8 meter per second. With this velocity, it will go up. So it will go on reducing. The final velocity will be equal to, for this place, for this condition, it will be 0. We'll see next slide now. We'll take a new slide. Yes, we have taken new slide. So what we have done, this is what, right? So for first condition we have done. Second condition also we have found out the velocity. Now what we have to find out? The time. So for second condition we have to find out the time. How will we find out the time? We know the distance, we don't know the distance, right? What we know that the initial velocity for this condition, bounce 2, is 37.8 meter per second, right? Final velocity is 0. Acceleration is how much? It will be minus g. acceleration will be equal to minus g, that will be equal to minus 10 meter per second. While free fall or falling down, any stone is falling, any ball is falling onto the ground, always remember the acceleration will be negative only. Okay, here you velocity is positive because it is going upward. So we can find out v is equal to, what we have to find out? We have to find out time, right? So v is equal to u plus a t. What is v? V is 0. Final velocity is 0, right? Here we can see we are talking about this bounce 2, bounce 2. So it is going from here to upward. While it is going from here to here, the velocity go on reducing, and here the velocity will be equal to what? 0. Initially the velocity was equal to 37.8 meter per second. 37.8 meter per second. So it will be 0 here. Initial velocity was 37.8 minus, okay, it will be minus, it will be 10 meter per second square into t. So I can write 37.8 is equal to nt, and t will be equal to 37.8 divided by 10, that will be equal to what? 3.78 seconds. This is for what? This is for bounce 2. So for bounce 2 what I got? For bounce 2 what I got? I got the velocity. Here I can say v, right? Here v velocity was is what? 37.8 meter per second, the initial velocity. This velocity, initial velocity, right? This velocity is what? Initial velocity for bounce 2, and time t is equal to t2 is equal to what? How much second? 3 point, you can say 8 seconds. 3.8 seconds. Now what is t total time? Total time is t is equal to t1 plus t2. What is t1 plus t2? 4 point, what was the t1 there? That means what? From here to here, how much was the time? 4.2 second. We got 4.24 second. From here to here, how much was the time? 3.8 second. So 4.24 plus 3.8 total time. Total time is what? Till here, till this point, what we got? 4.24 plus 3.8. It will be somewhat, this will be 4, 6, 7, 8, 9.47 seconds something, isn't it? What was the total time? It will be 8 point, sorry, it will be 4, 3.8, 4, 8, 9, 10, 0 point 1 carry 4, 5, 6, 7, 8, 8.04 second. So it will be 8.04 second. Now but the time that we have, time span that we have been given is t is equal to 0 to t is equal to 12 second. T is equal to 12 second. Okay, that means what? Now we have to take bounce 3 also. From t is equal to t2 is equal to how much? This was what? Total 3.4 second, right? Now from here to here, what will be the velocity here? Initial velocity. Now here velocity is 0. Now we have to find out this distance. We have to find out this distance covered, right? Okay, so this distance covered and the final velocity here, we have to find out the final velocity here. So how will we find out? Okay, so we will take bounce 3. This is about bounce 3. While bouncing 3, initial velocity is what? It is coming back. Sorry, it is coming back, right? Initial velocity is what? Initial velocity is 0. Final velocity we have to find out, right? Acceleration again we know minus g, it will be minus 10 meter per second. See, understand here. So total time, that means here what is t is equal to 12 second, right? Here total time was t1 plus t2 actually. So it will be 8 point what 03 second. How much did we get? Sorry for the disturbance. How much did we get? 8.04 seconds. So time is 8.04 seconds. From 8.04 second time to 12 second. So how much time is left? The time for which it will come from here to this point. How much time will be there? It will be t is equal to 12 minus 8.04. So it will be somewhat 12 minus 8.04. Right? 12 minus 8.04, it will be 9, 10, 11, 3, 3, 3. So it will be 2 point, right? 8.04, 4. Wait a minute. It will be 6 here. So it will be 9 here. It will be 2 here. 2.96 seconds, isn't it? Right? 2.96 seconds. It will be 2.96 seconds. Now for 2.96 seconds. So for 2.96 seconds, it is traveling to this point during bounce 3. So what will be the velocity here? Velocity will be equal to u plus at. This formula we can use. So this will be v. What is v? We have to find out. What is u? 0 minus 10 into what? 2.96. The answer will be v. It will be equal to 29.6 meter per second. Right? Now let me draw the diagram properly so that you can understand. Okay. So my situation was, I got all the values now. So there is a ball, okay, which is falling onto the ground. This is ground. Let us say this is ground. So it is falling onto the ground. What was the distance? Distance was 90 meter. Distance is what? 90 meter. The ball 90 meter. So what was the velocity here? What was the velocity? Velocity was 0 here. What was the velocity here? It is 42.4 meter per second. Okay, velocity is 42.4 meters per second. What is the time taken? Time is equal to t is equal to t1 is equal to, this is how much? 4.24 second. 4.24 second. Now from here it is bouncing back. It is bouncing back. When it is bouncing back, what is the velocity here again? It is 0. Distance will be less than 90 meter. Now what was the velocity? Sorry, velocity was 0 here. What was the velocity here? It was reduced. Reduced to how much? It was reduced to 37.8 meter per second. 37.8 meter per second. Then it came back. So what was the time? Time is equal to time taken to travel from here to here. That time was 3.78 seconds. So bounce 3 is important. While bouncing 3 is important means it will come back here. So what I have to find out? See, at time is equal to, now total time is what? 4.24 second, then 3.78 second, then time at time is equal to 12 second. What is the time is equal to 12 second? What is the velocity that I have to find out? The time is at 12 second means what? This I should know. This time I should know. What is the time here? 8 point total time 8.04 second. So from 8.04 second to 12 second. So how much time it has traveled? It has traveled a time of 2 point, sorry, it has traveled a time of, it has a travel it sorry it has traveled a time of 2.96 second. While traveling for the time of 2.96 second, the velocity that it gained here, the velocity here, it will be equal to 29.6 meter per second. How much? 29.6 meter per second. So this is how much? This is velocity 0 here. So let us draw the graph. Let us draw the graph here now. Which graph? Speed time graph. What did I tell you? Whatever variable, whatever variable is independent, it will come in x-axis. So time, it will come in this axis. Now let us understand, speed will be always positive. So take only, while you are drawing some plot, take only the magnitude, not the direction. Okay. So let it be 10. Let this be 20. Let this be 30. Let this be 40. Let this be 50. So let this be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Till 12 seconds you want. See, now what is happening? Let us draw the graph slowly. Now from where we are starting? We are starting from this point. Which point? This point. What is this point? V is equal to 0. At this point, what is the velocity? What is the speed now? Speed is 0. From here, the speed will increase. Till where? Till which time? What is the time here? 4.24 second. Right? So 4.24 second means somewhere here. Somewhere here. At 4.2 second, what is the velocity? This velocity, 42.4 meter per second velocity. So this is the point that I'll get. 4.2 seconds somewhere here. So this is the point I'll get. This is the point. So I have to merge this point. So this is which velocity? Velocity is going on increasing till this point. Till this point means this point. So till this point it goes on increasing, and now the velocity decreased to 37 point. What is that? 37.8 meter per second. Time will be same. The point will be same. So this is 37.8 meter per second. Okay, 37.8 meters per second. Now from this point, it is going upwards. It is going upwards against the acceleration due to gravity. It is going upwards. Then what will happen? Now it is going upwards means its velocity will be reducing. When it is coming downwards due to acceleration, it will increase. This acceleration due to gravity, it will increase. Now when it is acting against the acceleration, the velocity will reduce. Velocity will reduce to 0. Now which time? Here time is this 3.7 plus 4.24, 8.04. 8.04 means somewhere here. 8.04. So the velocity will reduce like this. This will be straight line. Okay, sorry for the line. This is 8.04. Now from 8.04 to 12 second, again this third bounce, it will come down. Therefore the velocity will increase. The velocity will increase, and increase, it will go to 29.6 meter per second, around here. This is how much? 29.6 meter per second. So this is 12 second, right? So it will increase, and it will go something like this. So this will be the graph. So what will the coordinates here? The coordinates here are 0, 0. The coordinates here are what? 4 point x coordinate is 4.2 and y coordinate is 42.4. And here the time is same, 4.2, and the coordinate is 37.8 meter per second. And here, okay, wait a minute, this line is not wrong. What is the coordinate here? 0, sorry, not 0, 8.04, 0. And this point here, 12, 29.6. So this is the graph, right? This is the speed time graph. This speed time graph. Are you able to understand? I'll just repeat it again. So what is happening here is we have a situation. Okay, what situation we have? The situation is this ball is been dropped from 90 meters, right? From 90 meters, Then what will happen? It will bounce. With each bounce, the velocity is reduced by 1/10. Each bounce, the velocity is reduced by 1/10. They are asking us to plot speed time graph from time duration t is equal to 0 to t is equal to 12 per second, 12 seconds. So what I have done, I have divided it into three parts. In first part, what happens? I am dropping the ball, it comes and strikes the floor, right? During this duration, what will happen? It will gain velocity. Okay, it will gain velocity. So velocity will increase, and at the point before reaching to the ground, it will have velocity v. That velocity v I have to find out. So I am taking only this path. I am taking only this path and applying the equation. Which equation? Kinematic equation. X is equal to ut plus half at square. By this equation, what I'll get this duration from where the ball has started, and it has first bounce, the first bounce that took place, the first time that ball touched the floor, that time duration I'll get. What is the time duration? 4.24 second I got. How much I got? 4.24 second. By this time duration, I have time duration now, I have acceleration, so I can find out velocity. What was the initial velocity? 0. V is equal to u plus at. Now this equation I have used. What was initial velocity? U. Final velocity I have to find out. A I know, minus 10. T I have calculated. T is T1. I have calculated 4.24. So what is the velocity? Minus 42.4 meter second. Minus, why it is minus? Because the velocity is acting downwards. Velocity is a vector quantity, is acting downwards. But I have to find out speed. So speed will be only 42.4 meter per second. Now, second case, second step. Second step means what? This, while it touches the floor, the velocity will reduce. It is given in the question. Velocity will be reduced by how much quantity? By 1/10 of that value. So by 1/10 means v by 10th, by v by 10th. So v minus v by 10. How much I'll get? 37.8 meter per second. Positive. It is going upwards. Positive velocity. 37.8 meter per second. So with that velocity, it will go up. It will go up. The velocity will go on reducing, and finally it will become here 0. So I have to find out the time also. So what I did, I have used this formula. V is equal to u plus at. What was v? What was the final velocity in this context? In this context, the final velocity. This is initial velocity. Now I'm talking about only this path, the second path, while it is going from downward to top. So here the final initial velocity 37.8, final velocity is 0, 37.8, 0. So it is 37.8, v is equal to u plus at, 37.8, v is 0, a minus 10, t I don't know, t I found out now, 3.78 second. So what is this? The time which it took to travel from here to here, time is 3.78 second. So how much duration is over? Duration that I have to find out is 0 to 12. How much duration is over? 4.2 plus 3.78. What is the duration that I have calculated? 8.04 second only. 8.04 second. For this duration, I have got velocities, I have got time, everything. Now how much duration is left? 12 minus 8.04. 12 minus 8.04. How much is the duration left? 2.96. That means at the third instance where my velocity was 0, now the ball will come back. The ball will come back, reducing the velocity. Now what was the velocity here? 0. The velocity will increase now, sorry. The velocity will increase. Now it will come to some point, right? Which time I have to find out? Till 12 second. So 8.64 minus 12. How much duration is left? 2.9 second. So for this duration, for this 2.96 second, how much distance it will travel? So what was the velocity here? 0. Initial velocity 0. Final velocity I have to find out. So I have used the formula v is equal to u plus at. So v is equal to u plus at. U is 0, a minus 10, t I know 2.96. Final velocity is 29.6 meter per second. So I got the graph. What was the graph look like this? What is the graph? Let's narrate the story now. From 0 0 it started, it fell down, so the speed will increase because acceleration due to gravity. The ball will be pulled downward, the velocity will go on increasing, then the velocity go on increasing, and the velocity will be 42.4, where before just before touching the ground. When it will bounce, then the velocity is reduced to what? 37.8 meters per second. It is reduced to 37.8 meter per second. So what is the time taken? 2 seconds. Time taken is 4.2 seconds for first instance when it touches the ground. Then what will happen? Then it will move up. While it is moving up, the whenever a body moves upwards opposite to acceleration due to gravity, the velocity or speed reduces. The speed is reducing. The speed is reducing. The speed reduced, and it becomes zero. What is the time span then? What is the time it took? 3.78 seconds. That means what? 4.02 plus 3.78. It will be 8.04 seconds. The velocity will be zero here. Velocity will be zero here. Now from here, it has to travel. That means what? From 8.04 second to 12 second. How much time is left? 2.96 second. So it has to travel downwards for a time period of 2.96 seconds. So velocity will increase at 12 second. The velocity will be 29.6 meter per second. So velocities are what? Velocities are 42.4 reduced to 37.8. Then at 12 second it will be